All right. Good morning, everyone, or good afternoon, depending where you are. Thanks for joining us here today for the Amazon DocumentDB virtual workshop. My name is Jason Lashour. I work with the DocumentDB team. We're going to get things started in just another minute or two. Looks like some folks are still trickling in. So we're going to wait till we get a little bit more of a quorum, and then we'll go ahead and get started. So for those of you who are punctual, appreciate you being here. And we'll get started soon. Thanks. Hi, everyone. So for anyone who's dialed in the last couple of seconds, we're going to get started with the workshop in just another minute. We're going to aim to start around 2 or 3 minutes after the hour. All right. Good morning and good afternoon, everyone. Thank you for joining us today for the Amazon DocumentDB virtual workshop. We appreciate everyone taking the time for this. Normally in normal circumstances that aren't on par for 2020, we would have loved to have done something like this at a local AWS office for where you guys live. But, given the times, we're adjusting to virtual. And again, we appreciate everyone taking the time to join us today. So I just want to go over a quick rundown of the agenda for today. This is a full agenda about Amazon DocumentDB, and we're going to have 3 sessions that range from about 30 to 40 minutes, and then we're going to wrap up with a Q&A. So the first session is going to be a technical overview of DocumentDB, which I'll be delivering in just a minute here. And then my colleague Brian Hess will be delivering a best practices overview of DocumentDB. And then last, we're going to finish. My colleague Karthik is going to provide a demonstration and overview on how to migrate to Amazon DocumentDB, which is a really common topic that we see. As I mentioned, we're going to wrap with a Q&A at the end. We're going to save a couple of minutes to address questions that you have. So everyone who's with us today should have the ability to enter questions into a chat. We're going to try and get to those throughout the presentation. And then, maybe some of the ones that require a bigger explanation, we'll talk about in that Q&A at the end. So feel free to keep the questions running and coming throughout the sessions today. And with that said, let's go ahead and get started. So just a quick introduction. My name is Jason Lashour. I'm a principal business development manager working with the DocumentDB team. I've been working with the service since we launched DocumentDB in January of last year. And, taking a step back before we get into too much detail about DocumentDB, just wanted to give everyone a very brief overview about how AWS thinks about building databases for our customers. For those of you who've used AWS, you may have heard the term purpose-built databases. For those of you who are new to this, the thinking behind this strategy is that rather than building single technologies that, single database technologies that are, able to store all data types and do all different types of data processing, instead AWS looks to build technologies that are built around specific data types or specific use cases like graph and search. And this isn't something that we, thought up in some type of a boardroom. This is really just coming from feedback that we hear from customers where they want to be able to use databases that are built around the use cases that they're designing, that they know are going to enable them to work with those data types, handle those use cases in a way that's easy for them to scale, easy for them to implement, etc. So Document is a a category that we got a lot of feedback from customers over the years, just as document databases have grown in popularity. We continue to get that feedback from customers who wanted to see a native service from AWS that was able to store and index and query JSON natively. So that's where DocumentDB comes from. We launched the service in January of 2019, and since then we've seen it grow very quickly. As I mentioned, just because we do see a lot of folks who have these use cases on AWS. So what is DocumentDB? It is a fast, scalable, fully managed, MongoDB compatible database service that runs in the AWS cloud. We're going to get into a lot more detail about all of these dimensions throughout the presentations today. And one thing that we like to talk about with folks is how we see customers using DocumentDB. It's a very common question that we get. And I think what we're trying to communicate with this slide is that we see customers, both startups, enterprises, various industries like financial services and media, who are using DocumentDB. But I think what's more important is how they're using them, is how these customers are using DocumentDB. And what we typically see is that, there's three very common use cases. The first is what we call move to managed, where customers may be self-running a document database, whether it's on EC2, whether it's in their data centers, and they want to be able to easily run that in the AWS cloud without having to worry about patching, deployment, scaling, backups, etc. So that's definitely the most common use case that we see. The second is what we refer to as purpose-built, where customers are deploying new applications. They want to use JSON as a data type. They want to be able to easily index and store and query JSON data. They want an easy way to manage that. So these folks look to deploy these workloads using DocumentDB just because it simplifies that overhead for them. And then lastly, we see customers who are refactoring relational databases, whether commercial like Oracle or open source like MySQL, to DocumentDB because they get the flexibility of working with JSON and not being bound to any specific schema. And again, it's a managed service, so it's easy for them to run it in the cloud. So I want to take a couple of minutes just to talk about document databases. And, I think one thing that we've seen over the years is that JSON has become a very common data type to work with. But when developers have to store JSON in a relational database, they have to use things like ORMs to be able to break up the data that's in the document and, store it as different strings and integers, et cetera, in that normalized relational format. So, while they're using the data, it's not necessarily easy for them to work with in the database because of these restrictions. And, I think what we saw a couple of years ago is that a crop of document databases such as MongoDB and Couchbase popped up to solve this problem by being able to, to natively store and index and query JSON within the database in a way that was much simpler than using these ORMs. And, in general, a couple of trends that we see in terms of why customers are using document databases. I think a lot of this comes down to the fact that, the document model is able to be easily read by humans. It maps naturally to how humans think about and model data. And again, that ability for developers to be able to have a flexible schema without having to do, any schema changes as they want to make changes to their applications. That flexibility for developers helps them iterate a lot faster. And then the flexibility to be able to do ad hoc queries and aggregations against that data, again, just continues to make it easier to work with. A lot of use cases that we tend to see pop up at the technical level are things like personalization, user profiles, content management systems. And taking user profiles as an example, right? So if you think about storing a user profile in a document format versus normalized data structure in a relational database, let's say you're a developer who's launching a new game. You have Susan Benoit's profile for that game. And then rather than creating a new table and having to do an expensive join across those tables to pull up Susan's score and rank, et cetera, for Exploding Snails, which is this new hot game that you've launched, instead you could store all of that information in Susan's document, and it's easy to pull that out. And then if you want to add, an array for something like a promotion, again, this is very easy to do. And I think the gist of it is that we see that developers are able to be more flexible when working with document databases as opposed to relational. But that said, there's a lot of challenges that come with scaling document databases. And that really comes down to the architecture of these technologies, and that they're fairly monolithic. In that the database software, the data, the caching, et cetera, they all run on single machines. And even though you might be able to replicate that data across multiple machines for high availability, and even shard it out for use cases that extend beyond what the database can store locally, ultimately that process of having to spin up a new machine, load data onto it, is something that scales very monolithically. If any of these machines fail and you have to recover them, it's a similar process. So they recover monolithically, and they don't really take advantage of the scale out distributed nature of cloud architecture. So a couple of ways that we see these challenges materializing are, let's say you want to add read capacity on demand because there's a marketing event or some type of a peak seasonal usage. That process with a document database looks like adding a new instance and then replicating the data from your replica set onto that new instance. Now, if you have terabytes of data in your data set, this is a process that could very easily take hours, if not more. And ultimately, that just impacts customers' time to market. And then similarly, if you want to recover from a node failure, right? So you may have high availability in the database so that you're not going to have any downtime. But you do have to recover that instance so that you have the same high availability target that you had prior to that incident. And that process is very similar, right? You spin up a new instance, you wait for the data to replicate. And while you can automate some of this so that you don't have to physically launch a new machine, you're still beholden to that replication time to hydrate that instance and have it come online in your replica set. What's tricky is that during that window, when you're running with reduced or degraded availability, it may have impacts on the read and write behavior of the database too. So, this is something that we hear a lot of feedback from customers on something that they want us to be able to simplify for them. And then scaling storage as your data grows, right? Databases, typically are only growing, not shrinking. So we often see customers, let's say this is an EC2 instance with an EBS volume that's attached to it. As that data set grows, there's monitoring that you have to do to the available disk space. Once you run up against the limit of that, you may swap that out for a larger storage volume. That's a maintenance that you ultimately have to undertake. And folks typically want to avoid those. And the challenge with a lot of document databases is that when you get to a certain amount of storage, you're either going to outgrow what you can use for that local disk based on the hardware limits, or based on the database vendor. At certain points, they may suggest that customers start sharding their workloads across multiple replica sets once you reach a certain storage threshold. And that introduces a lot of challenges that a lot of customers typically look to avoid. And then backing up data, if you're running your own MongoDB replica set, you may be taking a snapshot from your EBS volumes, or you may be doing something like taking a full Mongo dump every time that you want to take a backup. And this is something that doesn't necessarily scale well because you have to take snapshots off of backup nodes so that you're not going to impact performance. The Mongo dump process can take quite a bit of time. And I think that what customers typically run into is that their backups may not have the granularity that they want. They may not be consistent with the primary and the replica. Naturally just creates a lot of challenges. And then while customers will use replica sets to be able to keep their data highly available, we also see that for non-production workloads, a dev or a test environment where HA may not be paramount, but having durable data is really important. folks still have to run these highly available replica sets so that they could maintain that data durability, so that if they lose an instance, they're not going to have to recover from a backup. Ultimately, what this does in a lot of situations is artificially inflates the customer's cost structure because they're running 3 instances in a scenario when they may only need 1. So when we built DocumentDB, we thought about a lot of these challenges that we heard customers share with us, about operational challenges for running document databases, and then obviously the need to have a managed document database service that makes it easier for folks to work with this data in the cloud. And what we found is that a lot of these challenges really came down to how the data was stored, in that this monolithic architecture where the database and the storage ran locally on one instance. That was at the root of a lot of these problems. So when we built and launched DocumentDB, we used technologies that enable us to decouple the compute and storage. And what that enables customers to do is to scale each of these layers of the architecture independently. And we're going to talk about a couple of examples and how this architecture sort of solves those challenges that we were just discussing before. But before I get into that, I just want to give a quick overview about how the DocumentDB architecture is structured, just to kind of give you a visualization of it. So when you launch a DocumentDB cluster, it uses EC2 instances, which are going to run in a region and be separated by availability zone. Each cluster is going to have a concept of a primary node, primary instance, which handles writes and strongly consistent reads. And then for customers who want to, scale out for additional read capacity and also for high availability, you scale through read replicas. Now, when you write data to DocumentDB, it's stored in what we refer to as a distributed storage volume, which is an internal service that AWS maintains. And when you write to the distributed storage volume, your data is replicated with 6 copies across 3 availability zones. It's self-healing, so if a disk or a rack or even an availability zone was to be impacted, that's all maintained as part of the service for you. So you don't have to think about configuring disk space or monitoring it or anything like that. Now, where this becomes beneficial to customers is that let's take that scenario of adding read capacity on demand. If you need to add a new read replica to, let's say run a report or handle some type of marketing event, with DocumentDB, you simply launch an instance. The amount of time that it takes for the instance to come up is usually about 8 to 10 minutes. And then it could immediately start reading from that distributed storage volume without the data having to load locally. And that doesn't matter if it's gigs of data or terabytes of data. And then if you want to recover from a node failure, so we automate this for you. If your primary instance, for example, becomes unhealthy, we'll promote one of your read replicas to be the new primary. We fail that over, which is a process that takes roughly 30 seconds. And then after that, we rebuild the instance that failed to reach whatever the availability target you had prior to that event. And again, because the data doesn't have to load onto this machine because it's not data bearing, that only takes a couple of minutes to bring online. And then the way that the distributed storage volume scales, it does it in a way which is handled automatically. So it has auto scale storage that grows from 10 gigs up to 64 terabytes per cluster. So as you write data to the service, we continue to scale it for you. There's no maintenances. There's no, monitoring that you have to, implement for available disk space. We automate this for you, so that's one less thing that you have to think about. And then for backups, as you write data to the distributed storage volume, we integrate that data with S3 such that customers are able to do continuous backups, which lets you do point-in-time recovery. So if you need to recover down to a specific point in time because there is data corruption or whatever else happened, we give you the ability to do that anywhere from the last 24 hours up to the previous 35 days. You configure that window and then you define the day, the hour, the minute, and the second that you want to recover to. For workloads that require a longer attention, typically for regulated industries like financial services, where you may need to have monthly backups, let's say for a period of 7 years or so, you can automate that. You can do that manually and take snapshots of the data, and you could store them for as long as you want. Because these backup processes aren't using any of the database software, they happen tangentially to the distributed storage volume. It makes it such that this won't impact any performance, and it's all managed as part of the service. And then because we decouple compute and storage, the architecture of DocumentDB is more flexible than you'd see in a lot of self-managed implementations. So what I mean by that is if you want to, let's say, run a non-production environment like dev or test, where you don't necessarily have a very high HA goal, but you want to make sure your data is durable, you could very easily run a single instance cluster in DocumentDB. The data that you write is still going to be copied across 3 AZs. So even if that instance gets turned off or it has to be restarted for a maintenance, we'll be able to recover from exactly the point where it stopped without you having to do any type of recovery or anything like that. So where this is nice is that you could greatly reduce your costs for these dev and test environments. Instead of running 3 instances 24/7, you could have one instance that only runs during business hours, which cuts down compute costs by over an order of magnitude. And then for scenarios where you need higher availability, we make it easy to add replicas in a short amount of time to increase the HA target and still maintain that durability. So a couple more details about the DocumentDB service. It's fully managed in that we handle all of the deployment, patching, replication, etc. That's all built into the service. We offer pay-as-you-go pricing, so there's no, pricing for certain features that aren't, that come with different tiers of the database. Instead, everything comes in one single cost with no long-term commitments. And what's unique about DocumentDB is that since it's built by AWS, it also integrates with a lot of the other AWS services that you may be using today. So for example, you could offload the monitoring to CloudWatch, auditing goes to CloudTrail. You can use CloudFormation to automate your deployments. You can use Glue to move data between different services. So, a common use case that we see is that customers want to have, perhaps a normalized view of the data that they're running in DocumentDB into a relational database like Amazon Aurora, and something like Glue enables them to do that ETL functionality in an automated basis. We also support Secrets Manager, which is a service to manage your database credentials. DocumentDB is built with VPC, so you could run it inside your VPC without having to do any peering. And this is something that we look to continue to expand over time as we get feedback from customers. So I want to spend a couple of minutes talking about MongoDB compatibility, because this is, in the name of the product. It's something that's very important to us. And what we mean when we say that DocumentDB is Mongo compatible is that you can use DocumentDB for workloads that you may be running with Mongo 3.6 or 4.0, and you can use the same drivers and tools with DocumentDB without having to necessarily make any meaningful changes to your code. That said, though, DocumentDB is not designed to be a drop-in replacement for MongoDB because we're not actually running any Mongo source code under the hood. Instead, DocumentDB is a database that we built from the ground up to be compatible with MongoDB. So, for example, if you were to use the $out operator with MongoDB, and you were to call that same operator with DocumentDB, you'd get the same results from DocumentDB as you would MongoDB, but it's a different set of technologies. And what that ultimately means is that there's some capabilities in the Mongo API set that we may not currently support, and that's all driven by customer feedback. So it's something where we can work with you and provide some tips for how to test and make sure you get the right compatibility to be able to use the service easily. In terms of why we chose the Mongo API, we hear feedback from customers that they love the flexibility of the API. It's very popular. I think this 60 million downloads is actually currently something more like 100 million downloads. But again, the feedback that we hear is that managing the database itself can be tricky. And, like I mentioned earlier, we prioritize, understanding what capabilities folks need from MongoDB, or rather from DocumentDB, in order to use the service. And we do, there's a couple of mechanisms that we have to be able to get that feedback from customers. We have conversations with folks all the time where they may tell us, we need feature X or feature Y in order to use the service. And we've also instrumented telemetry into the service such that if you were to create a cluster and you were to try and build an index or use an operator in aggregation stage that we may not support, on your end, you'd receive an error. And on our end, those errors get packaged up into a report that gets delivered to the engineering team on a daily basis. So that way they have, sort of a real-time pulse check on what corners customers may be bumping into. And we work backwards from that feedback to, deliver capabilities that folks need. So last year we launched support for over 40 APIs for MongoDB, as well as some bigger features like slow query logger and change streams. And then this year we've, bridged the gap with a bunch of other aggregation stages and engine updates, security features like role-based access control, and then features that are specific to AWS like instance types and the ability to do snapshots across regions. Now, this is something that we, expect to continue to do, and there's, a lot more that we have in store for the rest of this year and obviously in 2021. And for those of you who may not have seen the announcement that we had last week, we just recently launched support for MongoDB 4.0 compatibility, which includes the ability to do ACID transactions across multiple documents. With that release, we made a couple of changes to AWS DMS, which is our database migration service. For those who aren't familiar with DMS, it enables you to use DMS as a proxy to push data from a source database, such as MongoDB, to a target database, such as DocumentDB. And it'll sync the data up such that the two will be, the two databases will be in sync, which enables customers to do zero downtime migrations. So what we changed with DMS for this launch is that we've added MongoDB 4.0 as a source, and we've added DocumentDB 4.0 as a target. So what that means is that it's easier for customers to migrate their 4.0 workloads to DocumentDB 4.0, and that it's also easy for customers who are already using DocumentDB to upgrade from DocumentDB 3.6 to 4.0, because you can use DocumentDB 3.6 as a source and DocumentDB 4.0 as a target. And in addition to the DMS launches, 4.0 capabilities, we also made some improvements to how we handle indexing, which we'll talk about in some of the later presentations. Now, in terms of how you scale DocumentDB, we touched on this a little bit earlier, but just to reiterate, we scale through read replicas, which the service supports up to 15 read replicas per cluster. That's a process that takes a couple of minutes. We also scale write throughput by scaling workloads up, which we make it easier for customers to do without having to migrate data from one cluster to another. You could simply swap out the instances because we have that decoupled compute and storage. As far as storage is concerned, we auto scale that from 10 gigs up to 64 terabytes. And those are really the three dimensions that we enable customers to scale on: reads, writes, and storage. From a security perspective, DocumentDB was designed so that it only runs inside your VPC. So you have very strict control over how you isolate the networks. We also enable encryption by default, so your data is encrypted at rest with KMS. You can also use your own customer managed keys if you want. And we encrypt data in transit using TLS. DocumentDB also adheres to a lot of the common regulatory compliances such as PCI, SOC 1, SOC 2, SOC 3, HIPAA, as well as some others that we have documented in our security documentation. We touched on backups earlier, so I don't want to belabor this point, but I think what we're trying to communicate here is that you have the ability to do point-in-time recovery as well as archive snapshots on an automated basis without any performance impact. And that's all managed as part of the service. So one use case that I want to talk a little bit about is Finra, who is a not-for-profit organization that's designed to ensure market integrity. And Finra was running a workload in Oracle that was storing regulatory filings as XML. And some challenges that they ran into are that it was consuming too much storage because they have a lot of downstream systems that are JSON based. It required a lot of engineering to be able to manipulate that data so that it could be used downstream. And then there was just the difficulty of managing the database and how it scaled. So Finra migrated this workload to DocumentDB so that they're able to store the data as JSON, which made it easier for them to index it and easier for them to query it, ultimately cutting down on their engineering overhead. So they were able to take those development cycles and apply them to things that were more differentiating, and also extend the usability of that data to those downstream systems. So I just want to give a quick overview about how we price DocumentDB. So we price on 4 dimensions. We price on instances, which we charge for by the hour. We price on I/O, which we price for by the million. Storage, which we price for by the gig. It starts at 10 cents a gig in US East, and depending on the region, there may be some variability there. And then backups are free for your initial data set. And then any additional snapshots or continuous backup retention that you have, we price at S3 rates, which start at 2 cents per gig. I'm going to skip past this migration guide only because we have a whole session dedicated to it. So we'll breeze through this for now. But I also want to talk about some programs that we offer for helping customers get started with DocumentDB. So if you're interested in any of these, you can talk to your AWS account management team. So we can help with things like cost estimates if there's a workload that you want to implement or migrate. We can help with deep dives, so we can look into your workload. We can assess, what things you may need to think about as you migrate, as you launch, have a chance to go over Q&A in a one-on-one capacity. The immersion day that we have listed here is essentially what we're doing today, so you can disregard this. And then we also have professional services teams within AWS that can help with overseeing how you implement the service, how you migrate workloads, work through you step-by-step for data modeling, performance optimization, and more. We also have some resources that we'll share again at the end of this discussion, but if you want to take a screenshot here, this is a good time. And essentially we, have blog posts, technical overviews, migration guides, compatibility guides, all documented within, the product details. So if you look up DocumentDB Resources, you'll be able to find all of this stuff very easily. So with that said, I want to thank you guys for attending the first session. And now I'm going to turn it over to Brian Hess, who's going to cover DocumentDB best practices.
Hello, folks. Just hitting go. So my name is Brian Hess. I am a Senior Solution Architect Specialist for DocumentDB. We're going to talk a bit now around some best practices after we've sort of set up the sort of groundwork that Jason led us through. So we'll talk about best practices in about 7 different categories, although they kind of flow from one into the other. We'll start with some cluster sizing and how to connect properly, scaling of DocumentDB, something that comes up quite often, indexing, monitoring, security, and cost optimization. So let's start with DocumentDB cluster sizing. So just to quickly reiterate this view that we'll return to a number of times here. This is the picture to have in your head. It's also what the slides will frequently sort of cover and come back to. On the bottom, we have our distributed storage volume. This is where the data is stored durably across 3 availability zones, twice in each availability zone, sort of following Amazon best practices. You don't directly interact with this storage volume. Instead, you interact with the top layer, which are these compute instances. These are going to handle client connections, query planning, caching, and returning results to the client. So when you spin up a DocumentDB cluster, you're going to choose the number of these instances and the type. There's various choices that we have for those. Another call out just to note here is if you're familiar with MongoDB, DocumentDB emulates the replica set concept that MongoDB has. And in similar fashion, one of these instances will handle all of the writes. This is the one in the middle called the primary. And then the other instances are called replicas. MongoDB calls them secondaries. We tend to call them replicas. They'll serve 2 purposes. One is if the primary has some sort of a failure, we have these other instances that are online already, and we can make one of those to be the primary, and we have sort of a short move over to keep the cluster running. The second is that they're connected to the same distributed storage volume, so that they can also serve read traffic. We'll talk about that a bit when we talk about scaling in a moment. So with that sort of backdrop, the first question that we sort of think about is sort of how many of these instances do I need? And there's really 2 ways or 2 dimensions to think about this on. The first one is really around your availability target. With DocumentDB, if we deploy a single instance, it'll run in a single availability zone, which gives us this availability target of 99% or 2 nines. With that one instance running, if it happens to go down, DocumentDB has processes in the background that are monitoring things. It'll detect that instance has gone down. It'll provision a new instance, get the database software running on it, and then make it online for connections. And that can take a bit of time, right? So spinning up an instance takes a little bit of time. We say 8 to 10 minutes. That's a pretty conservative estimate, but it's a good one for planning purposes. So the next thing we can do is we can add another instance. So 2 instances, one will be the primary, one will be the replica. If we put that into another availability zone, so we're spread across 2 availability zones, we pick up another 9 of resilience. So now we end up at an availability target of 3 nines. We get another benefit beyond just the availability target is that the recovery time is much shorter. As I mentioned, the instance is already running the database software, and so we can take one of these instances, or this instance that is the secondary or the replica, and we can promote it to becoming the primary, which will keep our database online for reads and writes. That process takes we say less than 30 seconds. I've seen it be a lot less than that, but another good conservative estimate there. We can add, so the 2 instances cluster configuration across 2 availability zones is probably what we'd consider the minimum for production. And that's largely due to this recovery time becomes much shorter, but also that our availability target is pretty high. Our best practice minimum configuration, though, is actually 3 instances spread across all 3 availability zones. That gets us to 4 nines of availability target. Again, we're still sort of in that 30 seconds or less failover, because having the other instances up doesn't necessarily change that. But we do get this extra availability. And so that's the best practice. It also happens to be our default configuration. Now, DocumentDB can expand to 16 instances, 1 primary and 15 replicas. But as we do that, as we add more instances, we don't get any more availability, but we do get some more read capacity. So the other dimension in which we talk about how many instances do we need comes to really focus on what is our read traffic need. And so the more instances we have, the more read replicas we have, the more queries we can route to those replicas to do read queries. And so we'll talk more about that when we talk about scaling, but that's the other thing that we think about is what is the read capacity that we're going to need will help educate the number of instances we want. So now that we've talked a little bit about the number of instances, which size should we choose? So DocumentDB has a number of instance size choices from T3 mediums, which we launched over this summer, relatively small, lightweight instance, good for dev test and functional and integration testing for sure, also good for light workloads, all the way up to really pretty beefy machines, these R5 24x larges with almost 100 cores and 3/4 of a terabyte of RAM. Now, what DocumentDB uses the RAM, about 1/3 of the RAM on a machine is being used by the database software, by the operating system, leaving about 2/3 of it for a cache. That cache is an important part of getting good performance from DocumentDB, just like a lot of other database systems. So there's about 2/3 of this RAM that we're working with. What we want is to make sure that the working set, so the working set is the data that we're likely to be querying. So if we think about a use case where maybe we have 3 months worth of data there, so around 90 days, maybe there's really only questions that are really coming in on a regular basis about the last 2 or 3 days. So we really only need sort of 3 out of 90, or about 1/30th of the data to be in this cache. We're also going to want our indexes. We're going to consult those on a regular basis. The indexes should also fit in the cache. And so the best practice for how to choose an instance size is to make sure that the working set and the indexes will fit into this buffer cache, this right-hand column. We're also going to, and we'll talk about this when we talk about scaling as well. The other dimension here is that since there's only a single writer in the cluster here, just like in a replica set, the more powerful the machine, the more writes per second that can handle. And since writes really are a lot different, it very depends on your application. They could be big documents or small documents. They could have a lot of indexes that we need to update when we insert. It's kind of hard to give a broad generalization. But the statement we can say is the more powerful the instance, the more writes per second we can handle. Now, the last thing I wanted to comment a bit, we'll talk about this when we talk about scaling, but when we try to get a sizing, this initial sizing estimate is really just to get us to a point where we can run an integration or a full-scale test with your workload to make sure that it actually meets the needs of that workload. And so we're trying to get about right. One of the things that we can look at, we'll talk about this in monitoring, is whether or not the cluster is looking like it handles the workload just fine, if it's a little undersized or if it's a little oversized. And if we do find ourselves in that situation, the architecture of DocumentDB makes it really easy to make an adjustment to that without really affecting the resilience of the system or its availability. And so and that's true not just in dev test, but also in production. So we certainly see times where perhaps your application is getting more popular, and so there's more traffic, and therefore we need to scale out or scale up, or potentially we got past a busy period and we want to scale in or scale down, and we can take a look at all of that. So the sizing is really just to kind of get us into the ballpark, and then we really want to test it. The other thing we'll talk about, I like to talk about here, is just because you really set up this backup retention period where you set up a window in which you can do point-in-time recovery. You set that up when you create your cluster, so when you're choosing the number of instances and the instance type. So now's a good time to talk about the backups as well. DocumentDB allows for this backup retention period to go from 1 day to 35 days. These are automated backup system that allows you, again, to restore to a particular point in time. And you can set this window. We suggest setting this window to cover your recovery point objective. So if you're saying you need to be able to roll back to, say, within 7 days, then we might set this backup retention period maybe to 8 days, just to give a little bit of a buffer. And then you can automatically roll to those. All right, let's sort of move on to then connecting. When you create a cluster, each of the instances in the cluster actually gets an endpoint. So you could connect directly to one of these instances. Now, connecting into one of these instances using the instance endpoint's a little bit, it's not an available best practice, an HA best practice, because it's possible that the instance that you wanted to connect to is down right now, or maybe it's been scaled in and no longer exists. And so we really want an endpoint that we know will actually allow us to contact the cluster. DocumentDB provides that endpoint that's called the cluster endpoint, and it will always point to the primary for the cluster. And since for the cluster to be up, there will be a primary. This provides an endpoint that we know will be able to communicate and connect on in to the cluster. And so using the cluster endpoint is really the way we want to get into the mix. I'm going to briefly mention that there is also a reader endpoint. This serves purposes in some sort of other cases and other systems. And I would say in general to forget about the reader endpoint with DocumentDB, because there are other mechanisms to allow you to contact the non-primary and spread things out. We'll talk about that in a moment. So really we want to focus on this cluster endpoint. Now, I mentioned before MongoDB has this concept of a replica set. DocumentDB emulates that. And what a replica set sort of is here, you think of it as all the instances in this cluster have access to the same data. And that's really what we see here with DocumentDB as well. If you connect in replica set mode after making the initial connection, the driver will consult the database to see and discover all of the other instances in the cluster and make connections to them. So this application contacts the primary over, say, the cluster endpoint, discovers the other two instances in the cluster, and then makes connections to them. It'll also know what the roles are of them. So it will know which one is the primary, which is where all the writes would have to happen, and which ones are the secondaries. So with that, we have a way that we know how to talk to at least one of the nodes in the cluster using the cluster endpoint, and we have a way to discover the rest of the nodes using replica set. And that's our best practice. Use the cluster endpoint, the part here that's in orange, and then connect in replica set mode, which is the part in green. If you're a MongoDB person, you'll know that replica sets can have a name that an administrator sets. In DocumentDB, that name, at least for now, is always RS0. Now, there was a question that came up in the chat around HA. And so one of the things that comes up is really sort of how does failure happen? How does DocumentDB handle failures that are in the system? So as I mentioned before, there's a process that's sitting and watching and making sure that these instances are actually healthy. If for some reason it detects that the primary has gone down, then that process will just choose one of these other instances to become the primary. That's a little different than the way MongoDB does it. In MongoDB, the replicas or the secondaries have a bit of a vote. Sometimes that involves having additional components in the mix, like arbiter nodes to break ties. DocumentDB takes a different approach. That process that's sitting in the background is essentially like a kingmaker process. It will unilaterally decide which one of the replicas is going to become the primary. We can control that choice with something called the promotion tier. And when you create an instance, you can set the promotion tier, which defaults to the same for all the instances. But you can set the promotion tier for a particular instance. And that will tell the kingmaker to prefer, it'll go through in promotion tier order, setting the, or making the choice about who is going to become the new primary. And that'll come into play a little bit later when we talk about some other components. So after we've made that move over to the new primary, well, we need to get back to full strength. And so in the background, DocumentDB will spin up another instance to backfill that replica, bringing us back to 3 instances. Now, when we connect on in, just sort of following along with connections, this used to be a slide that we spent more time on when these limits were lower. As Jason mentioned earlier, that there's a steady cadence of improvements that we've rolled out. One of them was related to increasing this connection limit, but there is a limit to the number of connections that can be made to an instance in DocumentDB. It scales now with the more powerful instances, can handle more connections, and it goes all the way up to 30,000 connections. The reason we're calling out containers here is that it's oftentimes with infrastructure as code where you might end up in situations where you have more of the applications deployed than you were actually paying attention to. So you just want to be a little careful that you're tracking that if there are lots and lots of containers that are hosting applications connected to the cluster, keep track of them because they do add up and you can kind of climb to this limit. I'll say that climbing up all the way to 30,000 does mean that some things have gotten pretty aggressive, but at the same time, applications sometimes need to make lots of connections. The other limit to call out, sort of these two tend to get talked about at the same time because they're both important, is cursors. So a cursor is created when the database wants to return more than a page's worth of data. And when it does that, it sends the first part of the data back to the client and then leaves open a cursor on the server so that if the client were to ask another question or to get more data, we already have some of these things already staged to answer that question. The problem is that they take up resources. And so we want to make sure that we don't overwhelm the cluster or the server with extra resources that we don't need. And so there's a limit to the number of cursors. And this is also increased a little more than tenfold. Now we scale again with the instances up to a little over 4,500 cursors. If you do find yourself bumping into the cursor limit, what we tend to see is that it's basically due to the fact that there hasn't been good cursor hygiene in the application. So you do need to explicitly delete a cursor when you're finished with it. Otherwise, the server still sort of expects you to come back. It can eventually time out. We'll talk about that a little in monitoring. It will eventually sort of say, okay, I'm gonna kill the cursor. This person hasn't talked in a long time, and it goes away. But if either of those things are happening, we'll probably want to go back to our application, make sure that we're gracefully stopping these cursors. So let's talk a little bit about scaling and how we scale up and out and in and down DocumentDB. The first part that we want to talk about, because this is going to come into play when we think about scaling our read traffic for the cluster, is really around consistency. So with the primary, since all write requests go to the primary, if you query the primary, then you will get back, if you read from the primary, you will get back the most consistent view of the data because it was responsible for doing the writing. So if your application needs read your writes consistency, you will use the primary for your reads. The challenge with that is that if the primary is doing all of the reading and the writing, well, it has to do the writing. It's doing all this other work as well. It'd be really nice to be able to offload some of that read responsibility from the primary to some of these replicas. Now, when the primary does a write to the distributed storage volume, it gets an acknowledgement and it sends back the result acknowledgement to the client. It will also send a notification to the replicas indicating, hey, there was just an update to this data. If you happen to have it in your cache, here's the new version of that data so that you don't return stale data. Now that message that gets sent from the primary to the replica can take a little bit of time. A healthy cluster, it's 10 to 100 milliseconds-ish. If the replica gets overloaded, let's say too much read traffic, et cetera, that number can start to creep up. It's one of the numbers we'll talk about in metrics. But it takes a little bit of time. So you can have a little bit of a window here in which a query to the replica won't have the most up-to-date version. This is a pretty common relaxation that gets done in the NoSQL space because a lot of applications don't need to have read after write consistency and can tolerate this slight delay in the staleness of the data. And so we can leverage the replicas as well. The replica will also acknowledge this back to the primary. We'll talk about that as a metric, which will sort of give us some indication as to whether or not the replicas are sort of keeping up with the incoming data. So if we look at that way, we sort of talk about, again, connecting as a replica set. One of the things that the replica set connection allows us to do is to set something called the read preference. What the read preference that we do set in the client indicates is, where would you prefer to read from? And so what our recommendation is to set this to secondary preferred. And what secondary preferred means is that a read operation will be routed to one of the replicas in the cluster. And it will avoid using the primary if there's a read replica that can answer it. If one of those read replicas goes down for some reason, then the reads will get routed to the other replicas in the cluster. And if all of the replicas are down, or if you're in a one-node cluster where there are no secondaries or no replicas, then as a last resort, it'll use the primary to do this query. And so that's sort of the place that we sort of start from. It allows for a really nice way where we can scale out automatically without having to modify our application. The driver is maintaining understanding of what is the topology of the cluster. And as new instances come in, the driver will automatically start using those instances because it's preferring and spreading the load across the secondaries. Similarly, if we scale back in, we don't have to do anything on the application either. The driver will see that an instance is no longer there, and it'll spread the load across the remaining instances. Now, there are some times where your application may actually need that stronger level of consistency. But usually we're able to do very well with this sort of secondary preferred or eventual consistency on our reads. So our preference is to set the read preference when we connect to have a default read preference of secondary preferred. And if you need to be able to, you need particular queries to have a higher level of consistency, you can set that on a per query basis. And so you can set and override the read preference to be primary for those queries that you need the higher level of consistency. So it might be an operation like creating an account where you want to make sure that you've got this higher level of consistency going on there. Now, there are some times where, from a scaling standpoint, it's handy if we look at sort of this asymmetric mode where we want to tolerate and optimize for asymmetric workloads, where we mean that there are some periodic times where we might need to have, say, a big number crunching type workload, maybe in analytics, it's rollups versus the normal transactional puts and gets kind of workload. And this is an example, maybe at the end of the month, we do some reconciliation and we do some reporting. We need to bring that in. Instead of having, because we're able to add instances to the cluster without moving any data around, we can actually add on in instances specifically for these sort of periodic workloads, where we might bring in a nice, powerful machine into the cluster. We'll use our analytics application, will connect only to that instance. So it won't connect in replica set mode, and it will use the instance endpoint. Sort of those aren't quite the best practices we talked about before, but they satisfy this particular need. And now our application is leveraging this machine to do the work. And the rest of the cluster can be used to do sort of the more day-to-day workload as we need. And then when we're finished with doing this work, we can just remove that instance out of the picture and kind of come back down to our steady, regular transactional workloads. So there are times where I mentioned that we have a single writer in this architecture, and there are times where the write workload might increase to a point where we need to add more capacity or write capacity to the cluster. And the way we would do that is to add or to change to a higher powered instance class than we have in the cluster. And so this is one way we could do it. We have our 3-node cluster here, R5 larges. One way we could do this is went the wrong way. We could add 3 more instances to the cluster. In this case, they'd be larger instances, the R5 4x larges. We can do that by having a higher promotion tier value than the existing cluster. And then we force a manual failover. That will choose one of these new instances, these more powerful instances, to become the primary. And then we would be able to take away the original instances. Now we have moved from a 3-node cluster on R5 larges to a 3-node cluster on R5 4x larges. We could end up in a situation where the workload has now died down. We got past our peak period, and we need to go, or we can go back to a smaller instance class, and we would do the exact same behavior, in this time just moving to a smaller instances, still again with the higher promotion tier, et cetera. And lastly, on scaling of storage, this one's pretty straightforward. Since you're not interacting directly with the distributed storage volume, we architected it in a way that just expands the more data you put into it. So it'll expand all the way up to 64 terabytes of data. There's nothing you really need to do here. You keep writing to it, and we'll just keep expanding to fit that need. So I did see a question here with multiple secondaries, and what happens, I'll come back to that picture, what happens with how that chooses to spread that workload. The way in which it does that, the driver actually has that built into it, and it largely does essentially a round robin to kind of spread that workload. The driver is paying attention to if nodes are being particularly slow. It might take a bit of a biased read, a biased choice there as well. But generically speaking, you could think of it as it's round robining across all of the read replicas, so you can get sort of an even distribution of those read requests across the replicas. All right. Okay. Monitoring. So the place we like to start with monitoring in terms of best practices is really around billing. It's nice not to be surprised by the end of the month. And so what we talk about is that you can go through an exercise to understand your application usage and get kind of what you estimate the cost will be by the end of the month. And we recommend then setting a billing alarm at about 50% of that spend, and maybe again at 75%. And what this does is it allows for you to kind of get an alert. If that alert comes at about the middle of the month, then you know you're on target, and that's just fine. If that alert comes on the 2nd of the month, then we might want to think about, revisiting how we sized things or our expectations. Maybe there's just a lot more traffic than we were expecting. It could be that we've chosen, the instance sizings or the number of them suboptimally, and we can get into how we handle cost optimization later. The point here is it's nice not to be surprised, and so that's like one of the places that we like to start. In terms of the cluster itself, there's really two ways to, or two levels to look at in terms of performance and how the cluster is operating. One of them is at the instance level, and one is at the cluster level. So we'll start by talking about instances. Probably the most important metric that we look at and we want to track is this buffer cache hit ratio. So the buffer cache hit ratio is essentially measuring when the database software needs to look for a particular page of data or a page of the index. Is it in the cache? We talked about the buffer cache at the beginning in sizing. Is the particular piece of data of interest in the cache or not? And we want to see that it is mostly in the cache, right? So we want to see this buffer cache hit ratio at about 90, 95 or higher % of the time. That's for a couple of reasons. One, obviously, like all things with cache, if you have a cache miss, the performance is affected, right? The whole point of a cache is that you don't have to go to this slower storage, either on disk or over the network. So there's a performance hit if there's a cache miss. DocumentDB, and we'll talk about this in cost optimization, and Jason mentioned it a little bit earlier, but DocumentDB also charges for I/O, right? 20 cents for 1 million I/Os. And so if we're missing the cache a lot, it means that we are going to the distributed backend and issuing an I/O, and costs can creep up that way. So we like to monitor this buffer cache hit ratio, maybe pay attention to it dropping below, say, 95%, maybe 90%, somewhere in that range. Now, the index buffer cache hit ratio is a subset of that. This is the number of times when you were looking for a page for the index, it wasn't in the, or it is in the cache. We want to see that even higher, right? Indexes are often used regularly with queries, and so we want to make sure that our index buffer cache hit ratio is nice and high as well. These next two ones that we want to monitor are really based on those limits that I mentioned before. The connection limit goes up to 30,000 depending on the instance class, and the cursor limit goes up to 4560 depending on the instance class. It'd be good just to know that we're not, that we haven't hit, or we're not close to hitting those limits, and then maybe be able to go do something. So if we see the database connections getting close to the limit, we might go and look at our deployment. If the cursor is starting to get close to that limit, we might go back to our application and see if we're handling good hygiene. And the last two metrics here on the instance level are really around basically the same as EC2, regular computer monitoring. Is the memory getting filled up? Is the CPU getting really overtaxed? Or the other way, if there's lots of free memory and there's lots of, and the CPU is really low, it could tell us that we might actually want to scale to a lower instance class, save a little bit of money. At the cluster level, I mentioned before the way that the primary sends the message over to the replica to indicate that there's a new piece of data in there, and that the replica will reply. The primary keeps track of how long those lags are for each of the replicas, and this replica lag maximum is taking the max across all the replicas to see how long that is. And we want to see this because if this replica lag starts to increase, it does mean that maybe one of these nodes is getting a little overtaxed, and we might need to scale up. But it is something to start investigating. We don't like to see that replica lag maximum drift up too high. I mentioned before that the cursors can eventually they'll just get reaped if they're not actually being used or accessed in 10 minutes. It's not the way that we like to handle cursors. So that's not really the best practice. So we want to monitor a little bit here of how often is the database feeling like it needs to go and do some cleanup and drop those old cursors. Volume write IOPS and volume read IOPS are how much the cluster is reading or writing to the distributed storage volume. Remember, we do a 4K write and an 8K read. And these are essentially what you're going to get charged for. And we don't, there isn't like a situation here where there's an alarm to set. It can be a really good investigative tool, though. If you start observing that there's some behavior that you found strange, kind of come over here and take a look at, am I doing reads and writes to the back end in some way that, I wasn't expecting. So one reason maybe that the volume write IOPS could go up is if there was all of a sudden somebody did a big data load and you weren't ready, you weren't aware of it. You could look here and be like, oh, geez, okay, I see. Big write spike. That's due to this, this analytics job that just wrote a bunch of data into the database or what have you. So it's a good investigative tool to look at, but it is also how we charge. And then the op counters is basically tracking the MongoDB operations that we're sending. So it does inserts and updates and deletes. It does read queries and cursor queries, et cetera. And so again, not something to necessarily alarm on, but it is again a good way when you're sort of investigating what's going on to take a look and see, hey, the cluster just got really busy right now, and it just got this huge increase in update operations. Okay, well, what is doing that? Let me go look at my my applications and see how that's manifesting. Auditing and profiling aren't necessarily in the sort of monitoring bucket, but we may as well talk about them here as well, largely because they get the monitoring and the profiling gets put into CloudWatch. And so that's where you'll find these events. We do auditing at the DDL level, at the authentication level, and role granting and revoking. And you can set alarms based on sort of how those things happen, like if there are 5 failed logins for a user in a minute or what have you. On the profiling end, you can set things up to enable profiling for slow queries. We go slow as 50 milliseconds or higher, so that can be set per cluster. And we can also set this to sample. Maybe we don't want every query that's slow, but maybe just every 10th one or what have you. Auditing and profiling are disabled by default. That's largely because they do move data over to CloudWatch, and as a result of creating CloudWatch usage, that's something that you get charged for. So we didn't want to have sort of a surprise charge there. So auditing and profiling, you have to set in your configurations for the cluster to allow to allow for those things to be enabled. So moving on to indexing. So indexing is used heavily in databases in general, and DocumentDB as well. And like most of the things that we have to say here are really the same as we would say with any database. Indexes come with a cost, and so you really want to make sure that you're only using indexes that you need. So we talk about constraining indexes really only necessary for the queries that you're using, and not having these extra queries. And one of the reasons there is the cost is not just size. We have to, store these things, and they occupy space on disk, but they also occupy space in cache. In addition to that, we have to update them. And so when we do a write to the database, we also have to update the indexes. The more indexes we have, the more work we have to do per write, and that can increase our latencies. In general, we say, you should keep the number of indexes to fewer than, say, 5 per collection. It's a real rough rule of thumb. There's certainly reasons why you might want more, and that would be fine. But I think if you're getting closer to, if you're getting to 5 or more indexes, we should probably have a conversation about what you're trying to do and whether or not, this is the right approach to handle that. And then the last thing about indexes, again, common to DocumentDB and basically any database system that uses indexes, is to make sure that you're really, for a particular query, returning a very small amount of the data. So things like a Boolean yes, no is a bad column to make an index on. Gender is another not great one. A customer ID or telephone number might be really good ones. So we want to keep the number, if you give a query, what percentage of the data comes back, we want to keep that to 1% or lower, really. On the right here, you can see that you can get some of the statistics about what are the indexes using some MongoDB APIs. On a collection, you can get the indexes there. On the collection, you can also get statistics. One of the statistics that comes out is the size of these indexes. And again, coming back to that concept with the buffer cache, we want to make sure our indexes fit into memory. And so we can see here what the sizes of these indexes are. These are relatively modest. They're just about 2.7 meg, so pretty small. And then last, I mentioned only put the indexes that you need. How do you know which indexes are really being used? Well, there actually is some MongoDB APIs that we can use to actually figure that out. We can go in and take a look at these index stats, and for each index, we'll see here on the bottom the number of accesses that have happened. So this particular index hasn't been accessed at all. And so that might be a good indication of an index we could go and drop. And we've definitely seen customers who've had indexes like these where they haven't been used at all. If we drop them, then the performance of the cluster greatly improves. Cost optimization. So as we mentioned before, DocumentDB is priced along 4 dimensions. The first are these instances, going all the way from the smallest instances, these T3s, mediums that are less than 8 cents an hour. We charge by the second, although we list the prices by the hour. The second is on storage, the amount of storage that we actually have in the distributed storage volume. A couple ways to think about it, but I think the easiest one is we basically charge you for the first copy of this data, and the other 5 copies are essentially free. So we're looking at it in terms of the amount of size that you as a user are thinking about being used, as opposed to adding in all that replication factor. The third is I/O. I mentioned this when we were talking about buffer cache hit ratio. So 20 cents per million I/Os. That's a 4K. That's a 4K write or an 8K read. And then lastly, on backups. When you create backups, that first 100% of your data is free. If you have backups that are bigger than that, either your backup retention period has gone larger than the 1 day, or you've taken some manual snapshots that you'd like to keep around. Those are essentially charged at S3 prices. So the first place when we think about where we can cut costs, the instances are oftentimes some of the more expensive components of those 4. And so we really get into a question of, do I need that many of them, and can I move to a smaller instance? So the first part of, do I need that many of them? I think go back to the sizing conversation that we had. What's our availability target, right? If this is a dev test cluster, I might not need 3 instances. I might be fine with 1 because I don't need 4 nines of availability. If it's, if it's a cluster that maybe is three instances. Can I go down to 2? Well, maybe I can if 3 nines of availability is sort of a good enough target. The second thing is really around instance size or the instance class. With the metrics that we've talked about, you can actually get a good understanding of whether or not the instances are underloaded. So they've got a lot of extra headroom. And that might tell you, like, if the buffer cache hit ratio is really high, that tells you that the data is in RAM most of the time, or the vast majority of the time. If the CPU utilization is low, it tells you that it's really pretty idle. We might be able to move from, say, an R5 4x large to an R5 2x large. I'd probably think about stepping my way through it because we can make these changes online, sort of move to a lower instance class and let it run for a while and make sure that that was a good choice, and maybe move again. One of the interesting ways to really save money is to turn off the instances entirely. So there's this capability to stop a cluster, and then restart it again later. When it's stopped, the data in the distributed storage volume is still there, so you are still paying the data costs, but you're not paying for the instances. Obviously, not paying for I/O because nothing is doing the I/O, and then the backups are not being created, so you don't have additional backup costs. This is a really handy thing to do for dev test. We see folks sort of stop clusters over the weekend, save a little bit of money, come back in on Monday morning and restart the cluster where it left off. One thing to note is that there's a 7-day limit. After 7 days, we'll automatically restart the cluster. That gives us an opportunity to apply any database patches or operating system patches that we want without the cluster sort of getting very stale. When it comes to I/O, I think we've talked a lot about these already. Make sure that the buffer cache hit ratio stays high so that the data stays in, the data you're needing is in RAM and you don't need to pay for it to go to the distributed storage volume. Be careful a little bit with TTL workloads. Those TTLs will cause you to create deletes. That's additional I/O that ends up coming on the cluster. There are sort of some more bulk ways to handle TTLs that allow you to sort of drop. If you put like a collection per day, then you can age off an entire day's worth of data by just dropping an entire collection, which is a much lower I/O cost. Actually, there's no I/O cost when you drop a collection. And then lastly, we'll talk about a little bit about securing. Best practices for DocumentDB, put it in a security group that allows inbound traffic just on the DocumentDB port, which is the same as the MongoDB port by default, 27017. And then allow your application to have a security group that can go and talk over that port to that cluster, to that security group as well. We have role-based access control with the built-in roles in DocumentDB. You can grant read-only access to all the collections in a database. You can grant read-write access to all the collections in a database. You can grant those to all of the collections in any database, admin privileges, etc. One thing to just call out is we don't yet have the ability to grant read or write access to a particular collection. So the way that we tend to talk about that in case people need to restrict like that is to put the collection in its own database. There's no real overhead for having each one in its own database. So if that's the way that you want to manage it, it's a perfectly good way to handle that case. I really already sort of talked about auditing and profiling. One of the other things in the security is that by default, there's a flag that enables deletion protection. The idea here is that you can't delete the cluster unless the deletion protection flag has been turned off. So this sort of makes for a two-step process. So you don't accidentally drop a database with, drop a cluster with terabytes worth of data. Now it's all lost. So what you would do is you would go and modify the configuration of the database to allow you to delete it and then to delete it. It's a nice little safety check. We use TLS to and from the database to the client. We use KMS-backed encryption at rest for all the data in the distributed storage volume, and in the cases where data needs to be written on the instances, say for a large sort or something along those lines. And then just a call out for the integration with Secrets Manager. AWS Secrets Manager has some nice functionalities for particular database credentials, where it can also rotate those credentials so they don't go stale. The way your application interacts with it is it would go to Secrets Manager to retrieve the credentials, the username and password, and then use those to log in to DocumentDB. And with that, I will send that over to Karthik. I think is going to take over for the next part.
Thank you, Brian. Let me get started here. Let me know if you can see the screen properly.
Yes, we can see it.
Awesome. Cool. All right. Hello, folks. My name is Karthik Vijayaraghavan. I'm a senior DocumentDB specialist solutions architect with AWS, and I'm going to be talking about migration to Amazon DocumentDB. Primarily, we'll focus on MongoDB, but we'll start by looking at what are the common sources of migration. So here at AWS, we see customers migrating to DocumentDB from various sources. Most of them come from MongoDB, like I said before, but we also do see customers coming from relational databases like Oracle, SQL Server, DB2, and so on. We do see key value users as well when they run out of the primary or key value lookup needs and get into the secondary lookup kind of a scenario. And then we see MongoDB. We also see other databases like Couchbase, like Jason was mentioning. And then we do see some search use cases which are no longer just inverted index-based lookups, but also need secondary lookups. So we see users coming from Elasticsearch as well. But like I said, for the most part of this presentation, we will focus on MongoDB migration because that's where most of the migrations come from. So we recommend customers to go through, 4 different phases. We like to see this as four migration phases. The first phase is discovery, and in this phase, it's all about figuring out compatibility. DocumentDB is compatible with MongoDB, but there are differences as well, and there are some APIs that are not compatible, and I'll talk about where you can find them in a bit here. And then the second phase is about planning, right? How do you want to do this migration? What kind of migration method suits you the best? It's again going to depend on what your situation is, and what your application or use case demands are. And then the third phase, this is the most critical phase, testing, often overlooked, but very important phase where you test your workload for functionality and performance in a lower environment before moving those changes into production environment. This might sound very trivial, but we've seen there's a lot of time where this step being overlooked, causes problems. And then the last phase is putting it all together and executing it, based on the options you chose in planning, following your test cases and stuff like that. So the link over there, covers these stages in greater depth. So please do refer to them after this call. In this session, we will go through at a very high level, like a crash course on what these phases, comprises of. So let's start with the discovery phase. So there are 3 main objectives here, right? Verifying that your application is compatible, right? And what are the considerations to determine migrations for your workload? And then, like I said, we're not 100% compatible with MongoDB. We do have some functional differences, some APIs that are not supported. So it's and all those are very clearly documented in our documentation in the portal that I'll share in a bit. So ensure that the APIs that you're using for your applications are compatible. And then sizing is another important aspect while you're in this space, right? It is important to size your instances appropriately for all the reasons that Brian was explaining in his session. And then inform the migration options, meaning understand what migration option is going to work for you. You can do an offline migration, you can do an online migration, you can do an hybrid migration. Understand what works for you depending on, again, your use case, your workload, and what downtime you can take or you cannot take. So let's talk about each of those now, right? Like verifying compatibility. What does that mean, right? So DocumentDB is Mongo 3.6 and 4.0 compatible as of last week. So it's typically best to migrate from Mongo 3.6 to DocumentDB 3.6. We have customers migrating from Mongo 3.6 to DocumentDB 4.0. All that works. But if you are on a lower version of MongoDB, like a 2.6, 3.0 or whatnot, the recommended or official online upgrade path is to get to 3.6 and then do the migration to DocumentDB 3.6 or DocumentDB 4.0. But having said that, we do see customers going from 3.0 directly to MongoDB 3.0 directly to DocumentDB 3.6. It works, but again, testing is going to be very important, right? There could be corner cases, and that path is not that we officially test. Our official test path to migration is getting to the latest version like 3.6 or 4.0 and then do the migration. Right? And when it comes to drivers, which is very important from your application point of view. So from a driver perspective, generally the newest drivers across all languages would work because they're backwards compatible. It's just like how it works with MongoDB. So there should not be any challenges as long as the APIs are compatible. And like I said, there are functional differences. For example, 3.6 version of DocumentDB, we guarantee atomicity and consistency. Even for operations that modify multiple documents, right? And with the last week's launch of DocumentDB 4.0, explicit transactions that provide asset properties for multi-statement and multi-collection, multi-database operations are not supported, right? So, but when you look at single document transactions, there is a functional difference in terms of how we guarantee atomicity and consistency versus how MongoDB does it. Likewise, if you're using MongoDB, the results are automatically sorted. With DocumentDB, you should be explicitly calling the sort of function. Dots or periods in the field names are not allowed in DocumentDB. So if your documents that you store in MongoDB today has dots in the field name, then you should change it before migrating to DocumentDB. And then if you're using sparse indexes are supported, but your query should use the $exists clause. So these are like some of the differences to call out, the main ones, and our documentation, like I said, covers it in greater details. And then service limits, right? There was some question in the chat as well on what is the connection limit and cursor limit. Now, these vary by instance types, and I think Chad already provided the link to what is the limit per instance type. But you can, Brian was showing you how to monitor the connections, and you can also go to the console and do a service stats command to monitor it. The key thing here to note is, especially with microservices architecture, we see a lot of workers that are doing very little work. And there are times where there are more connections that are created than required, resulting in wasted connection. Again, as you know, connection is directly proportional to resources on the server. So make sure that you're using appropriate defaults depending on which driver you're using, as the connection pooling varies by the driver. And you use connections in a frugal way. Right? Again, this is not just specific to DocumentDB, it is for any databases, right? So understand how connection pooling works and use that to its strength, right? You can monitor database connection, database max connection metrics to keep an eye on this and make changes to the application. It could be like, hey, should we increase the pool size, decrease the pool size, or should we scale our instances up so that we can support more connections? So understand the service limits because those are going to be different than what you're used to in MongoDB. And then, like I said, supported APIs, right? We support most of the commonly used APIs, and we continue to add support. You saw in Jason's presentation, at least for those of you that saw that, we have added a lot of operators and compatibility support since we launched, right? And we continue to add that by working backwards from our customers' needs. So it is important that you test your application with DocumentDB and ensure that there are no unsupported APIs. And then the good thing is when you run your application by pointing to DocumentDB, you would get those exceptions if the APIs are not supported. So there's no, it's not going to be hidden or eaten by the application. You will be seeing that exception on your console. So at least point to DocumentDB and test it to understand. And again, a documentation clearly calls that out. And we also have, like, with the recent release of 4.0, we have another table that says what is supported in 3.6, what is supported in 4.0, since when we added the support, and so on and so forth, making it easy for our customers to understand what is supported and since when it is supported. Again, testing, cannot emphasize more on this. There's no substitute for testing. It is very, very important that you test your application after you point to DocumentDB. And also deployment types. With MongoDB, we see all the three types of deployments: standalone, replica set, and sharded clusters, right? DocumentDB by default is deployed with one replica set. So if you are running on a standalone MongoDB cluster and you want to migrate to DocumentDB without downtime, then we recommend that you initiate replica set using the RS initiate, because replica the op logs are required for minimum downtime migration, and doing an RS initiate would help you get the op log going. So you don't if you're okay with a downtime migration, then you don't need to convert the standalone deployment model to a replica set. You can just use a dump and restore and be done with it. But if you want like no downtime migration, oplog is required. For that reason, you would convert it into a replica set using RS initiate. And if you're already on replica set, it's the most straightforward and most common deployment that we see, and it's pretty easily you can migrate that using our database migration service, or using dump and restore, or a combination of both of them. And if you are running on a sharded cluster, DocumentDB as of today does not support sharding, but if you can still, we have customers migrating their sharded clusters into DocumentDB, and the approach to do that is to migrate these shards in parallel. Because like I said, we don't support sharding yet. So when you migrate in parallel, it's basically migrating one replica set per shard, right? So we have seen customers doing that, and it just works fine. And then like this is the documentation I was talking about. So if you go to the link over there on our developer guide, you can see the functional differences called out. You can see the supported APIs and data types called out, and you can also see this migration guide. And then last but not the least, the quotas and limits. This has come up a couple of times in the chat as well. So you can access all of these, and we keep this up to date as we release new versions and make improvements and enhancements. So from compatibility in the discovery phase, moving on to the next step there, which is sizing and costing. So it is very important to understand this, because this is what is going to make up your bill. So, what are the key things here to understand, right? So your read and write rates at peak and sustained load, because this is what is going to determine the IOPS. And as Brian was explaining, DocumentDB does bill you for IOPS. So understand what is your average writes per second, reads per second, and peak, and what time of what is the percentage of time you spend at peak write and peak reads, right? So this is important. And how do you do that? How do you get this information? You can either use MongoStat, or you can use op counters to get this information, right? For example, this screen that you're seeing here, right? We're using op counters, and you can easily say anything that is get more and query, combine them together to understand what's your read traffic. Likewise, your insert, update, and delete together is going to give you the write traffic, right? So you can easily get this information. Okay, looks like the screen share went away for a minute. Okay. And then data characteristics also play an important role when it comes to sizing and hence pricing, right? Because your average document size, for example, right? So it's important to understand what is your current data footprint and how it grows, and what's your average document size. Document size will have a direct impact on IOPS, because we do IOPS by 4K size document for writes, and 8K size document for reads, like Brian was explaining. So it's important to understand and plan for it, right? Backups, they also contribute to your cost. Like while the first day backup is free, as you increase the retention period, there's going to be a cost for the incremental data growth, right? So understand your RPO and select the retention period appropriately to ensure that you have the right amount of data backed up, and you're not paying more money for that. And then like I said, retention policies, we do support TTL, and in a couple slides from here, I'll talk about some alternate strategies which will help you to save costs. And the reason we call this again and again, like you would see similar information in the best practice as well, because this is how it's different than MongoDB. So we would like you to think along these lines so that you're optimized for cost at the same time, achieving your RPOs, RTOs, and your requirements for the use case. So how do you gather the data characteristics? Again, you can use MongoDB Stat, In this case, the average object size gives you the average document size. The storage size gives you the footprint. There is an index size that will give you the index footprint as well. And you can calculate the data growth by simply understanding what's your writes per day or writes per minute, however you compute it, right? So you can easily calculate what the data growth is from there, so that okay, from 6 months from now or 1 year from now, where you're going to be in terms of your footprint, in terms of your document size, and so on and so forth. So these information together will help you to size your instance and how much memory and CPU you need. There are a couple more things that I'll cover in a bit here in terms of availability and performance. So backups. DocumentDB supports backup up to 35 days. You can take backups anywhere between 1 and 35 days, and this directly translates to the point-in-time recovery window for restores. Right. So if you want to restore, if your RPO or recovery point objective is 30 days, then you select your retention period to be 30 days. Right. And TTL, while we support TTL, we often see customers finding an alternate strategy more helpful, which is like having a rolling collection. For example, if you want to retain data for 2 months, then have data and you access only data for, let's say 1 week's data frequently. Group them into one collection and keep dropping the collection every 9th collection, which is basically gonna keep you with eight weeks of data, which is 2 months, right? So group the documents into collection and then drop the collection instead of deleting data or deleting per document will help you save IOPS and cost, and it's also much better in terms of efficiency in how you do that, right? So those are some alternate strategies to TTL. But again, if TTL is what you want to do, that is also supported. So again, that's one difference in behavior when it comes to Mongo and how you'll be seeing the price or the cost in your bill. And then talking about source configuration. So this is on your MongoDB side, right? So oplog size, this is very important because, like I said before, oplog helps with minimum downtime migration. And these migrations can take a long time depending on how much data you have. And if you size the oplog too small on your MongoDB, you may cap the size on the oplog. And the result of that would be like new changes would not be replicated and you might run into issues. So it's very important that you size your oplog that is big enough for your migration. I typically recommend my customers to do it at least 1.5 to 2 times more size than what your how much time it's going to take to migrate data. For example, if it takes the oplog of size X lets you migrate 1 terabyte of data, just do a 2x size, right? So that you don't run into this oplog capping. So that is very important. And a replica set and sharded cluster, we talked about it before. So if it is replica set, it's pretty straightforward. Sharded cluster, make sure that your shards are migrated in parallel. And then now that we have completed our compatibility assessment, sizing assessment, and all, let's move to the planning phase. So the first step before we jump into the migration approach, online, offline, hybrid, is to determine the cluster requirements. Right. So what does that mean, right? So we talked about sizing, but how many instances do you need, and how do you determine that, right? So Brian talked about this availability, right? So your availability target is going to determine that to begin with, at least, right? So if you have 4 nines of availability as your availability target requirement, then you need 3 instances at the minimum, right? DocumentDB supports up to 15 replicas in addition to one primary instance. And if you need 4 nines availability, 3 instances, which is 1 primary and 2 replicas, are the minimum requirement. Now, how will you know if you need more than that? That's where your performance requirements comes in, right? What is the CPU or compute requirements, and what is your memory requirement? So compute requirements is tied to how much parallel queries you want DocumentDB to process, right? So it's very important when you migrate from MongoDB, understand your queries and their index needs and determine the compute requirements for your workload. And the other half of it is about memory, right? Like Brian said, 2/3 of the available RAM is available for the working set memory. Remaining is used by DocumentDB control plane. So if you know that your working set should be let's say 20% of your data, and then what is your index size? As long as your index and working set fits in memory, you should pick an instance along those lines, assuming that you've already figured out your compute capacity. So compute and memory together will help you determine, what size instance you're going to be picking over here, right? So if you know that, okay, not more than 4 parallel queries across different users, and 32 gigabyte is what is my working set and index, plus 1/3 of the memory for control plane, then R5X large is the instance that you would be choosing. And the number of instances you can always scale as you go. So start with 3 for your 4.9 availability, keep adding the instances as you need. And then the migration approach, right? So this is where we have like 3 different options, right? So the first option is the fastest and simplest one, where you can just use Mongo utilities like Mongo dump and Mongo restore. So step by step, walking through this picture here. So your application first stops writing to the MongoDB database because you don't want any changes to come in that you would be missing. And then you dump the data and indexes. And the best practice is to pre-create indexes on your DocumentDB side, right? Because index creation in DocumentDB is sequential. So when you update the data, index updates are parallel. So it will be faster if you pre-create your indexes, and then you can use Mongo restore to restore the data. And as the data is being restored, the indexes are also going to be updated. And then once the data is completely restored, you can simply change your endpoint for your application, which was originally pointing to MongoDB. Now it will be pointing to DocumentDB. Again, this is all assuming that you've done the discovery phase, verified compatibility and sizing and all that stuff, right? So like I said, this is very simple approach, but the downside is there is going to be downtime, right? Because between step 1 and 5, depending on how much time it takes. Now the good thing is Mongo restore is you can use the multi-threaded approach and go faster. But still, there's going to be a downtime, right? So if that is applicable for your use case, then fine. If not, you can use the online approach, right? This is using database migration service. So database migration service supports MongoDB as a source, both DocumentDB 3640 as a target. So your application will continue to point to MongoDB in this case, and you still pre-create the indexes, which is again a best practice, right? So you pre-create the indexes. And then you work on your DMS task. So you create a source endpoint for MongoDB. Then you'll create a destination endpoint for DocumentDB. You create a task that just connects the source and destination endpoint together. And you can say, in that task, you will say perform a full load and replicate with the CDC mode. So what does that mean is it first does a full load migration. If let's say you have a terabyte of data, it does a full load of the data. And then it continues to replicate ongoing changes from there. Again, this is why it's important that you have your op log sized appropriately, so that after the 1 terabyte data migration is done, the op log still has all the changes that took place after that 1 terabyte that can be now migrated into DocumentDB. And then in this approach, right, like you have like near real-time synchronization happening from MongoDB to DocumentDB through the CDC via DMS. So you can choose a time and then cut over to DocumentDB. So that's going to be your only downtime between the cutover, right, from MongoDB to DocumentDB. So it has very minimal downtime. In the last 3 weeks, I think 3 weeks ago, we also improved performance on our DMS, where earlier you were able to migrate data in sequence. Now you can do it in segments. So you can do more parallel processing of data. So that will help with performance in terms of doing the full load with DMS. So the complexity wise, it's medium because you have to create a source endpoint, destination endpoint, task and stuff. It is not as simple as just doing a dump and restore. But again, it gives you the benefit of minimum downtime. Now, what if you want to increase the speed here? Let's say you're not migrating 1 terabyte, but you're migrating, let's say 20 terabytes or more, right? Because DocumentDB can scale up to 64 terabytes in storage. So, it's not uncommon for folks to bring in higher, data volume. So then this hybrid approach might come handy, right? Because in this case, right, it's a combination of your dump and restore and DMS. So your application continues to still point to MongoDB. You use Mongo dump and restore just for the data. Likewise, pre-create the index. That is common across all the 3 approaches. And then you restore the data, then use DMS. In this case, you're just going to enable it for replication, but not full load, because your full load is handled by your dump and restore. Now, once you do that, this will be a faster approach because with restore you can use multiple threads, quickly upload it, and also take care of replicating your ongoing changes through DMS. So the setup is a little bit more involved, but again, it's faster than the online approach, and it has similar downtime like online approach, which is very minimal. Right. So again, this approach would work if you really have large data set and want online migration. The hybrid approach would be the way to go. So in all these approaches, like I said, the pre-creating index is a step that we recommend for again quicker migration, better performance, and all that stuff. And for that, we have this DocumentDB index tool, right? So this is again a free tool that you can use. It's available in the GitHub link over there. All that it does is, it helps you in two ways. One is once you create a dump of your MongoDB indexes, this tool, it's a Python script which goes and reads the indexes, and you can say, hey, identify if there are any compatibility issues. A good example is we do not support geospatial indexes and text indexes right now. So if you have any geospatial indexes, then it's going to tell you, hey, you have this index that's not compatible, so that you can prepare a plan for a workaround, right? So it gives you the compatibility issue. And you can also optionally say, okay, skip the incompatible index and pre-create all the other indexes, right? So you can ask the tool to do that as well, and it will create those indexes for you. So it's really handy when you have a lot of indexes and you want to migrate them without worrying too much about what is compatible, what is not. The tool handles all of that for you. So again, if you want to take a screenshot, feel free to do that. You can access that in the GitHub. And then phase 3, right? This is testing. Except for these few items here, which I'll go through, there's not anything that I would say is very unique or specific to DocumentDB, right? We talked about pre-creating indexes. I mean, do this if where possible, because this saves a lot of time with migration. And oplog, this sizing is very important, especially if you're migrating a larger data volume. Make sure that your oplog is sized appropriately. And with sharded clusters, ensure that you turn off the shard balancer, because with balancer turned on, you could run into orphan documents, and then it could result in duplicates and all those issues where you'll have to go and do cleanup. So the cleaner way to do that would be turning off the shard balancer and just migrating the data with each shard in parallel, or one replica set at a time. So other than that, right, the standard test plan elements apply here too, right? So if the overall goals and success criteria for your migration, it's very important, right? So how much time is it going to take? Is it within your maintenance window? What is the go no go criteria, right? Like how are you going to validate it, and what is going to be your point where you determine this is a successful migration or not? Because it is also important to have a rollback plan. What if you're not able to move within your maintenance window? How do you roll back? Who are the owners? How do you inform them? Again, standard stuff if you have done any migrations before, but just wanted to call out because it's very easy to overlook these things, especially when you're migrating to a fully managed service. And then, test the actual application. Again, I've mentioned this multiple times before, right? So testing is important, and inform your teams, right? Maybe your front-end team, back-end team, DevOps team, whoever is supposed to be aware of this migration so that they're available. And when you do a testing in lower environment, time the migration, right? At least if not the same data volume, at least similar or equivalent data volume. And then it helps you to determine if your migration is making progress in the maintenance window. And then, with AWS folks would be more than happy to help you when you're doing this migration. So keep us informed, and preferably do this during business hours, so that if need be, we can even bring in our extended teams, like the people that are working on the service, right? So those are some of the considerations. And let's say you have a clean test plan, you've tested in lower environment, you're all good to go. Last step is very simple, just execute it, right? If you have all the planning done appropriately and compatibility discovery done appropriately, this phase should be, relatively easy. So you follow the test plan, make sure you track the progress, you understand how much time it's going to take, and perform the migration, and ensure that if you have any partners or customers that you have to inform, let them know as well, because if there's going to be a downtime, if you're doing it in business hours, then it's important to keep your stakeholders informed. So that's a quick overview on migration. Like I said, it's more of a crash course on what we have in our documentation. But there are more questions. Happy to take them. And also wanted to let you guys know that we do have this DocumentDB from the dining table, a Twitch show that Chad Tyndall and our product manager deliver. I think it's every other week. So the next one is coming up on December 3rd. So feel free to join and ask questions and learn more about DocumentDB. With that, thank you so much. And Jason, I'll turn this back to you.
That's great. Thanks a lot, Karthik. So folks, we're going to take a couple of minutes now to do some Q&A. It looks like there have been a lot of questions that have come in through the chat, which is great. So if you have any more, this is a great time to ask them. We'll take a couple of minutes to take some Q&A, and then I'm going to transition to some resources that I want to close out with to help you guys as you're getting started with the service. So I guess just to make good use of time, I'm actually going to fast forward to those and just keep this slide up for the last couple of minutes. So we do have about 10 minutes left for Q&A. And just to go into some more detail on what these resources are, the first is a link to a hub that we have on the product page for DocumentDB. This is a really, really good link to bookmark. It has documentation, blog posts, key announcements, video recordings of similar sessions that we've done. So some of the content here, for example, has been used in other presentations for events like reInvent that we have bookmarked there. So it's really a one-stop shop for anything that you may need to know for DocumentDB. Anything you need will be there. In addition, there's also a link that we have down here for a DocumentDB immersion day. So if you have a specific workload that you're looking at migrating or that you're looking to deploy to DocumentDB, you have questions about, how you're going to execute that. Is this workload the right fit? Deeper questions about the product, etc. You can request one of these workshops through this link, and it has all the routing to be able to notify us so that the bat signal goes off, and we'll be able to help you out. So these are two useful links to bookmark. Definitely suggest that you keep these handy. And with that said, we'll start taking some questions now. If anyone has any that they want to add in here. So let's see. Well, doesn't look like any questions are coming in just yet, but we'll give it another maybe another second or two.
Yeah, and Jason, if there's any other questions from the chat that you want to call forward and just go over, so people hear the answers instead of maybe seeing them, or maybe they joined later, they can't see the previous messages in the chat window. That's another thing we could do as well with our time, if you want.
So it looks like Vibov NJ had asked a question: is it possible to get a link to these slides? We don't have links that we'll be sharing out as a follow-up, but I believe that this session will be recorded, so you'll be able to access the content, in some capacity. And if you have, an AWS account team that you work with, just reach out to those folks. They could get in touch with us, and then we can, get your hands on the contents that you have at handy. I'm just scrolling back to see if there's any other questions that we didn't have a chance to address here. Wow, Chad, you've been answering a lot of questions, my friend. I owe you a big thank you.
All right, yeah, Brian and Karthik and I have been in here mixing it up for sure. This is great. A lot of good activity in the chat.
Excellent. All right, folks. So I know it's been a long morning or a long afternoon. We appreciate everyone who's been sticking it out, and obviously everyone who attended today. So with that said, I think we're going to wrap a couple of minutes early. Chad, I know that you had some closing comments that you wanted to share, so I'll turn it over to you.
Yeah, Karthik mentioned our Twitch show, DocumentDB from the Dining Table, the next episode in 2 weeks at the same time slot, 11 a.m. Eastern time on December 3rd. It's a really fun show. We go behind the scenes with our principal product manager, Joe Idzorik, and we pull in various principal engineers and other solution architects come on. We have guest speakers, and we really go deep into various aspects of the service, how it works, how to best use it, how to, tips and tricks for best practices, how to avoid, any common pitfalls that we've seen customers fall into. Sometimes we take support tickets and we go through what happened and how things were resolved so that other people can avoid the same problems in the future. So it's a lot of fun. If you're interested in what you saw today, I encourage you to come back and join us 2 weeks from now and learn some more information about the service there.
Wonderful. All right. Well, thanks a lot, everyone. Have a great day.
All right. Good luck. Thank you.